Okay, so for testing amperage, always place the meter leads in series with the circuit. Okay, in series. We have to open up the circuit. If we're doing this at school and we're measuring parasitic draw, which is when the computer starts pulling power out of the battery when the car's off, we do it at the battery disconnect, that little green dial that you find on the battery. We hook the meter leads across those 2 points, before it and after it, and then we unscrew it. That lets us get the amperage reading. Now, the reason why it's good to do it that way is because let's say you're driving the car and let's say the fuel pump relay that's operating the fuel pump sticks, and that's what's causing your drain. Well, if you disconnect the battery, that relay disconnects. If you do it this way, the battery stays connected, you hook this in line, and you unscrew it, and now the relay stays engaged because it's connected through the meter, right? Next thing you see is make sure that the circuit does not carry more current than the meter can handle. Most are 10 amps. That's what you want to protect, stay below. Most meters have a fuse. Lots of them do not. So if you have a meter that is not fused and it'll say it on it, you blow the meter up. Start on the highest scale and work your way down, right? Opposite of resistance. There we're starting on the lowest and going up. Amperage, we start at the highest and we come down. Once again, our meters are auto ranging. We also can hit the range button and it will move the decimal point to be able to display larger numbers. If we have more than 10 amps, then we're going to use an inductive pickup that clamps all the way around the wires. And then it picks up the magnetic field going through it and it figures out the amperage from there. Okay, we measured voltage drop. We mentioned this in the last lesson. We're comparing 2 points. If there is no change between 2 points, all is good. If there's a difference between the 2 points, that's bad. But that all depends what you're trying to measure. So let's take a look at what this says. Testing the power side of a circuit, connect a red lead to a positive post of the battery and the black lead to the power wire at the load. Okay, so everything goes back to the battery on the power and the ground side. If you're hooked to the battery positive and you go to your radio, right, your radio should have that same voltage on that battery that the battery has. By doing that, we'll measure how much voltage is lost all the way from the battery through the wiring, through the plugs to that radio or to whatever component you're measuring. With the power on, the reading should be less than 0.1 volts. If it's more than that, there is some item in there that has resistance in it that's causing voltage to disappear on its way down. If the reading is higher, there's excessive resistance in that power side. Same thing goes for the ground side. Testing the ground. Connect the red lead to the ground wire at the load and place the black lead at the negative post of the battery. Same thing. You want that ground to be a good connection all the way to the electrical device. If your reading is good, it should be less than 0.1 volts, just like on the other side. If it is higher, then somewhere in that wire, you have a problem. Now, the way we would do it is we leave our lead on that negative side of the battery and we start measuring that ground side moving further away from the battery. We keep going, we keep going, we keep going, we keep going, we keep going. All of a sudden we hit the part where now it changes. So now we bring it back until it comes back to a good reading. And now we know that's right in the wire where the problem is. Right? Turn the power on, should be less than 0.1 volts. If the reading is higher, big resistance someplace. Additional things that we can do. Sometimes we can measure engine RPM. The dwell is the timing, the pulsing of the ignition coil. We can check diodes. We can check the condition of the distributor if it has one. We can measure frequency. We can measure temperature. We can check electrical noise. We can measure duty cycle, which is the pulsing on and off. Pulse width, which is also a pulsing to like a fuel injector. The pulse width goes up as the injector sprays more fuel. Now, the biggest thing that comes in with meters is the decimal position, right? So I gave you this as a little way for you to keep track of things. The biggest things that we deal with, and I can zoom in here, right? We deal with mega, we deal with kilo, we do milli, we do micro, and we usually don't deal with nano or pico, but I guess it could come in all depending on what you're measuring. Basically, if it's mega, 6 positions of the decimal place, right? You can see we move it this way, 6 places. If it's kilo, that's 3 places. If it's milli, it's 3 places the other way. And if it's micro, 3 places the other way. So we're either going 3 positions to the left, 3 positions to the right. Naturally, if you have smaller readings, you should get more of stuff, right? Same thing as like you have $1 or 100 pennies, right? $1, 100 pennies. So you think about it as you're looking at this and you say to yourself, should the thing get bigger or should it get smaller? And then this is some different things. So what happens is here at school, we have you using a J-kit to do all your measuring. A J-kit has terminals that go into the device and go into the plug, and we extend the circuit out so we can do our testing and gain access to it. In the field, we will do back probing. And if we look, right, first of all, we can touch the contacts. These are back probes. And here's how we use them. We slide them in through the weather pack connector on the back of the plug, and we try to touch the terminal. Sometimes we got to wiggle it around a little bit, and we can get our readings there without disturbing the circuit at all. The problem with doing it at school is that the students would absolutely kill our stuff. They would destroy everything. They'd shove it in there, and they'd just keep pushing it. And so we don't let you back probe at school, but you would in the field. These clips are pretty cool because basically you pull this back, the black piece falls back, you slip your wire in there, it clips back on it, we turn the dial and it pierces the wire. Right? And you can see here, that's what's happening. The negative is that you put a hole in the wire, right? And you can hurt the strands of wire that are inside. So if we punch a hole, we have to seal that hole up afterwards. Okay? Very useful tool, but you have to understand what you're doing. And then lastly, the inductive clamps, right? Where we're not disturbing anything, we're just touching it from around it, and it's picking up the magnetic field that's created as current flows through the wires. And they're pretty amazing too. Okay? So the next video will have me performing the actual hooking up of meters.